All right, so now what we're going to do is we are going to start by creating the simplest setup that we can that will represent a pair of gears, but we don't want to have just any pair of gears. We actually want our SolidWorks engine to do most of the lifting for us in terms of sizing out the gears that we're going to use. So I'm going to give SolidWorks what I want out of my gears, and then it's going to tell me what I need to make that happen. Sound good? If you want to follow along, I've also got this lesson overview posted up on Canvas. The one that's there now is still last year's, but I will be posting the updated version probably sometime between today and Wednesday. And most of the stuff we're going to be starting with is the same as last year's as well. We're just going to go to a little bit deeper level than that time. So I'm going to start by making a part in SolidWorks. And this part's actually going to be the back plate that I'm going to attach the gears to. So go into SolidWorks, click on part, click on OK. I did open it on apps, and I actually opened it through cloud paging. And I think all of these guys already had cloud paging open. Did you ever get cloud paging open to run it? Yeah. Is the single sign-on not working for you, Marza? Do you know if you logged on to SolidWorks from any of the computers in here before? No? Yeah, do you have a laptop? Stefan was able to get in on his laptop. Is there SolidWorks on your laptop? Oh, you have a separate copy. Do you have a copy on your laptop from last year? Yeah, I do have it, but it's not home. Ah. Do you want to try and use Steven's laptop? You have. Yeah. We're not going to go super fast. If you guys have any questions, please feel free to stop me. Once I've got this part open, I do want to be in inch pound second, just because I like British metric units. I'm just used to them. And then once I'm in inch pound second, I'm going to start by creating a sketch on the front plane, which again, just because it's a personal preference. On this sketch, I'm going to lay out a few things, and then I'm going to come back into here to add dimensions later. So what I really want is I want two posts that I'm going to attach my gears to. I'm going to have two circles that represent my gears. I'm actually not going to have those touch, and that's going to be important here in a little bit, but just don't draw them touching, leave them separate. And then I'm going to connect those two center circles with a horizontal center line. And I've drawn them different sizes because I want my gears to have different sizes, so that way they have an aspect ratio that's not 1-to-1, just to start off with. That makes sense? I'm actually going to make this a two-dimensional representation of what the gears need to look like, because that's going to be my first set point for do I need more? And what I'm going to design is not the gears themselves, but the enclosure that holds the gears. Most of the time, you're going to buy gears off the shelf. You're not going to make them. So what I'm going to do is, if I know that this gear needs to be this big, I'm going to turn this first circle into a construction geometry. Right click on the second one, turn it into a construction geometry as well. And then I'm going to build an enclosure around that that's kind of just bigger than the gears themselves. So to do that, I'm going to use the offset tool to offset a 0.25 inch offset from each of these circles. And then I'm going to use the line tool to connect the circles such that they're basically one feature. Yeah, I'll do the whole thing again. Let me just finish out this real quick so you guys can kind of see what this is going to look like. So when I get this done through here, it's going to look something like that, where we just have the outside profile. Let me go through the whole thing, kind of start to finish one more time. And you guys can follow along if you didn't get the first time. So again, I'm starting with two circles. Doesn't really matter how big they are. I'm going to come over, I'm going to do two more circles. I want them to be different sized. That's maybe a little bit too different. And I'm not having them touch because I don't want to get a relation there. I want that to be driven by some equations I'm going to put in here in a minute. I have a center line connecting the centers of the two circles. And then I did an offset of 0.25 inches from each of the two circles. Oh, I don't want this line actually. Let me delete that one. Go back to my offset, get that guy. And then I'm going to close off the top and the bottom. I do want that top line to be tangent. If I don't get the tangent relation when I add it, I'll just go back in and I'll add it after the fact. So that bottom one, it gave me the tangent. The top one, it didn't. I'm just going to click on the line, hold control, click the circle, and then select the tangent relation. Same thing on the other side. I'm click on the line, hold control, select the tangent relation. Now I've got those tangent. And I want to trim these out. I'm going to use the power trim just to trim the top portion. And I'll do the bottom portion as well. Then I think I'm just going to delete the extra lines. So I'll exit the power trim tool, click on the line, click delete. And I'm not going to be worried about my dimensions yet. I have a 0.25 dimension from my offset, which is still there, but I'm not going to worry about that. I just want to put some geometry on the page. Anyone have trouble drawing that sketch? Oh, I did convert these to center lines as well. So I'm going to right click on those, convert those to center lines. I want those to be center lines because again, I'm drawing what would be a case for some gears of a specific size, not necessarily the gears themselves. And so this makes one closed contour because it ignores the center lines when I go and do the extrude later. Questions on that? Everybody able to follow along with that okay? Mars, are we able to catch up a little bit? Not quite yet. We'll come back to this, so hopefully it should be okay. All right, I want you guys to go ahead and exit your sketch. We're going to come back into that sketch in a minute. So if you didn't finish, don't worry about it. You can come back into it and try and catch up. But what I want to do is I want to use equations to drive this part. And really, when you're designing something in SOLIDWORKS, if you're not using either a design table or global equations, you're probably not doing a super good job of engineering that part. Because this is one of the things you can do to what we call a parameterize or to set design parameters that you're going to control in the optimization of the components. So what do I want out of a gear set? Or what do I want to be able to define in a gear set? It's going to be important. What's the most important thing I want out of the gears? What do gears do? They turn. But why would I want to add a gear head to an assembly? Why did you have gears on your bike? Why do you have sprockets on your bicycle? Do you want the speed of the back wheel to be directly proportional to the speed that you turn the crank at a 1-to-1 ratio? Usually you have a bigger sprocket on your crank and a smaller sprocket on the wheel, right? Because you want the wheel to be able to go faster in terms of revolutionary or revolute velocity, right? Then you spin your wheel, your crank. So most times you're adding a gear is because you want the output speed to be different from the input speed. How do we determine that in a gear set? What property of the gears do we look at? The circumference? Is it just the circumference of one gear or is it the circumference of both gears? Both gears. So it's really the gear ratio, right? It's the ratio of the size of one gear to the size of the other gear. And so most of the time when we're looking at gears, what we're concerned about is the gear ratio. So I'm going to add a variable here for the gear ratio. And I'm just going to start it off as 2. If I'm going to be putting this assembly into a larger, this is like a sub-assembly inside of a bigger assembly, right? I usually have a spacing that I need to be able to use. So on the bike, there's a distance between the crank, right, where the pedal is attached to, and the rear axle. And I may want to change the gear ratio, but I can't change that spacing because that's just the size of the frame of the bike, right? So a lot of times there's a spacing between the gears that's going to be constant, and you have to make the gears fit together regardless of what gear ratio you want. Does that make sense? So I'm going to say there's a spacing between the two gears. I'm going to set that as 2 inches. You'll note that in here I put in 2 inches and it evaluated to 2 inches because I put it in inches and my units are in inches. I always like to put in my units because then if it evaluates to something else, I know I accidentally forgot to change my units. So do it at least once, right? And I'm going to go cheat. I'm going to use my sheet here. The next thing I want a pitch, which determines that's the size of each of the teeth of the gear. It's the spacing between the teeth, really. So I'm going to say there's this pitch, which is not really that important of a design parameter outside of the gears, but it's important for the gears themselves. And then I also want to have the size of the gears that I need that maintains both that spacing and the gear ratio, which if you remember the radius of gear 1 plus the radius of the gear 2 has to equal the spacing for them to mesh properly, right? So I can use that relationship to calculate these equations. I'm not going to derive those for you guys here, but I have this in diameter. It's 2 times, I'm going to do gear out. Sorry, diameter out, diameter. So I know it's a diameter out. And I set that as 2 times the spacing. And I have to put the spacing in quotes. So do quote spacing, just as it shows up here above us. That divided by the quantity, so I'm going to use parentheses, 1 plus quote gear ratio. And it doesn't matter that you spell correctly. It only matters that you spell consistently. So if your spelling is wrong, that's fine as long as it's consistently wrong. If it's inconsistent, then it won't work. It says 0.1. Oh, DIAOUT. I don't know if there's a way to make the font on this bigger. And then for this one, what I want to try and do is I'm going to put in a 1 here real quick. And I'm lazy. I'm going to copy this equation. I'm going to paste it in. I'm using Control C. So I'm holding Control and pressing the C key to copy it. And then holding Control and pressing V to paste. And then you'll notice that this equation is really the same thing, except for it's plus 1 over the gear ratio. And that just makes those two things add up to the same quantity. And I got to use double quotes. And you'll notice here that if I were to divide each of those diameters by 2, so I got radius instead of diameter, and then added them together, I would get 2. I'm going to leave that up there for a few seconds to give you guys a chance to make sure you copied it down. I know typing in the equations can be kind of difficult, especially if you're reading it off the screen. And I know Canvas is down, so you might not have access to this lesson overview page. If you're curious as to how I resolve those equations, if you just assume that the radius of the input gear plus the radius of the output gear is equal to the spacing, and the ratio of the radius of the input gear to the output gear is equal to the gear ratio, you can get that equation just by resolving them in terms of diameter out and diameter in. So it's the system of equations. You guys don't want me to do that, do you? If you do, I can. I just don't think it's worth it. Any questions on that? Everybody got that typed in? After we've got that typed in, go ahead and click OK. And I'm going to put those parameters into my model. So I'm going to edit my sketch. I'm going to right click on sketch, click edit sketch. If you guys fall behind, please let me know. Otherwise, I will just keep going. Marza, did you ever get this? It is diameter. So I can still pull it up from here. Diameter in equal 2 times spacing divided by 1 plus 1 over gear ratio. Yeah. Stefan, how about you? You okay? And so I'm going to specify this as my input gear. So I'm just going to set the diameter here. I'm going to say equals. Whenever you want to define an equation in SOLIDWORKS, start with equals. If you don't start with equals, it will still let you put in the name of the variable, but it won't set it to update with that set. so it won't work properly. So I'm going to say diameter in to the left-hand side, and then enter. I'm going to go over to my right-hand side. Oh, I'm going to hit OK. I'm going to go to the right-hand side. I'm going to specify its diameter. I'm going to say equals to global variables diameter out. Enter. And then I'm going to set the length of that center line equal to my spacing. And it broke this last line over here. But that's because it's underdefined. So I'm just going to exit the Smart Dimension tool. I'm going to drag this guy over. See if I can get it to fix itself. If it doesn't fix itself, I can always just redraw it. Yeah. So I'm just going to hold Control, get those two centers, make them concentric. And then I do want the offset between this line and this line to be 0.25. And I lost my tangent relations, so I'm going to add those back in. I'm not sure when I lost those, probably when I did my trimming. Ooh, doesn't like that. If you get an error like that, I highly recommend that you just Control C. Wait, do I have an extra line here? That's supposed to be my inner diameter. I'm just going to redraw this bottom line. And I'll just trim out and get rid of the old one. I'm not sure what's causing that to have an issue. There you go. And I'll set the two center circles to have diameters of 0.25 just so they're fully defined. All right, I'm gonna walk around and check and see where you guys are all at. Define, like you trimmed the circles are supposed to be the ones that are construction lines. The outer ones are supposed to be the solid line. Just turn that one back to a solid line. Yeah, and then make your center one. Five offset from that circle, within that circle. Sorry. Oh, it's very far outside one. Offset. Just do an offset, and you offset around that construction circle and then trim it out. Should define our circles first. Yeah. I just connect the top line with the bottom line. You want the offset there to be yeah, 25. Yeah, add a concentric relation between that circle and your center circle. The one on the very right. Yeah. And the distance between the top of that circle and your right circle. Take that. Add a relationship to this. All right. So as you guys are finishing up, one of the things I want to note is if my goal was to find a set of gears that would mesh properly, have a center spacing of 2 inches and a gear ratio of 2:1, this is pretty much all I need. And go online, find a 0.26 diameter gear and a 0.12 diameter gear that have the same involute profile or whatever profile I decide to use, order them, boom, set, done, right? I don't have to do anything else. I may want to extrude this and go into my features, do extruded boss base. It's a thickness of something reasonable. I'm going to use a 1/4 inch again. Now I've got a mounting plate that I can use to maintain the spacing between my gears. And maybe I put a cover over that and I call it a day, right? If for some reason you can't find those gears and you want them to be exactly that gear ratio with exactly that spacing, you may decide that, okay, I do want to design my own gears, but I want them to be parametric such that if I decide to change the gear ratio or the spacing or any of those other parameters in the global variables in the future, they automatically update. Because again, most of the difficulty in designing a gear goes along with the profile of the gear, which we're actually going to do last. So we're going to use the ancient Mayan technology of non-slipping smooth gears to start us off. And we're going to add the teeth and the complexity in later. Sound good? All right. Before we do that, one of the things I want to do is I want to use the same set of equations for all of my gears. I don't want to have to type them in again, right? So what I'm going to do is I'm going to export these variables from this part, and I'm going to use that to make my gears. So to do this, we open up our equations, which I can do right-click, manage equations, or I can go to tools, equations, just like I did the first time. And then from here, you'll notice there's an export option. So I click on where it says export. Be careful where you're exporting to. I typically suggest that you make a folder specifically for each project. So I'm just going to make a folder called gears. I didn't mean for it to be caps lock, but sure, why not? And I'm just going to call this gear equations. I'm going to save. I'm going to say, what do you want to include in this? I want to include everything except for these dimensions. I don't really care about the dimensions there in my file. I only care about my global variables. So the gear ratio, the spacing, the pitch, the diameter in, the diameter out, those are the ones that I want to include in this equation. You'll also note that the link to file box is checked. Because that box is checked, you will automatically have the equations in the part linked to the file that I'm creating. If you uncheck it, they're not linked. It's just exporting it without saving it. So I want that box checked, and that's the default. So I'm just not going to mess with anything. Any questions on that? I'm going to hit export. You'll notice that all of these have turned gray. And now the link to external file box is open. I can click on the open folder button. There's this file. Now, in this part, which I haven't saved yet, so it's probably save it. I'll do save as. I'm going to go back to my gears folder. You do want your all your files to be in the same spot. I'm going to call this gear plate. And then I want to show you all. You can follow along with this as well. I'm going to minimize that one. If I change something in this file, say the gear ratio, it's probably the most obvious, and then save the file, and then rebuild my part, that automatically changed. And if I show my sketch, you can actually see those gears and the size they should be. And I can get this to be kind of ridiculous. Right. Or I can go with a bigger spacing. Oh, let's go something bigger. Go big or go home. Maybe my input shaft's kind of small by comparison. Probably you wouldn't want to do that. But good design is resilient to changes. So if I set these things up properly, I can use almost any combination of gear ratio, spacing, and automatically get the size of gears I would need for that to work, and a part that's derived from those sizes. So I don't have to worry about, are my gears going to fit? If this back plate fits into my assembly, the gears are going to fit too, because they're the same size, right? So next thing I want to do is I want to make some gears. They're going to be super simple, but they're going to use the same sizes inside this plate, and they're automatically going to update whenever we update this text file. So I'm going to do a new part. Click on OK. I'm actually going to make sure this is in inch pound second right off the bat. It's always a good idea. Make sure you're in the right unit system before you do anything else. I'm going to save this because it's usually also a good idea to save your parts before you do a bunch of other stuff. I'm just call this gear in. It's going to be my input gear. I'm going to save as, actually, I'll do that later. I'll make the other one after I do some work. I'm going to import my equations. So almost the exact same operations as we did to export the equations, but we're going to import them. So I'm going to go to Tools, Equations. And you see there's import right next to it. There's my gear equations. Because I saved this part to the gears folder, it's looking in that folder by default to get the equations. If you don't see the equations, make sure you're saving in the same directory. And just in general, when you're working in SOLIDWORKS, whenever you're working on a project, have a directory for that project with only that project's files in it. Otherwise, you're going to have all kinds of issues with files having the same names or whatever, and it's going to be a problem. So click on that file, click open, and say, what do you want to import? Do you want a link? I want to import all the equations, and I do want a link, which is the default. So I'll just go ahead and import. You notice that it pulls it in. The screen now looks almost exactly like the screen I had from my gear plate file, right? Everybody see that? Yeah. Pedro, following along still? Good. Caitlin, you good? I see you still have the gear plate open, so I'm worried. Don't worry about it. You don't want to use the plate. You can worry about that later. So go ahead and try and follow along with this part. That's one thing I will say. If you guys are stuck on something, your two options that are valuable are ignore it and move on. Especially if you can get a confirmation from me that that's not going to impact your ability to continue to the next part, or let me know. Otherwise, getting people caught back up takes a lot of time, even with only a few people. So I've got my new equations imported. I'm gonna click OK. And this gear is gonna be super simple. I'm gonna sketch on the front plane. I'm gonna get an input shaft diameter, basically a center diameter. And then I'm gonna have a outer diameter, which is gonna be the gear diameter. I'm gonna say that equal to global variables, diameter in, enter. And then the center one, I'm just gonna make 0.25, so it matches my gear plate. And I'm gonna save it. Now I could do my second gear exactly the same way, which Caitlin, you can follow along with if you want. I can do new. If you guys want to, you can also just watch this, but I'm gonna do it a different way again in a second. Go back to the front plane, do my two circles. I forgot to input my equations, so I'm gonna import my equations. Open, use the defaults, okay. And then I can make this one my gear out. I'll do 0.25 to the center. And this one equal to global variables diameter out. I'm in MMGS, which is wrong. Fix that real quick. So I could have this be my second gear. Or if I was smart and realized that, hey, my input gear and my output gear are basically the same thing, rather than remaking the output gear from scratch, what I can do is I can take my input gear here. I'm going to extrude this to a 0.25 inch. I can say, okay, well, I'm just going to save this as my output gear. And then the only difference between the two of them is that this one is driven by the diameter in, diameter out. Oop, I didn't mean to cancel that. I wanted to accept it. There you go. There's my output gear. Right? One of the things that the parametric design will allow you to do is to have multiple variations of parts that you've developed very, very quickly just by changing those parameters. And so this is one of the ways that you can express this. I know my input gear and my output gear are going to have the same basic profiles, right? They're going to use the same math to determine all the parameters. I just got to change the in to out and I'm done. I do want them to be separate parts in this case because I want to put them into an assembly. And so I want them to have different sizes. But you can even have configurations instead of separate parts if you really wanted to. And we'll cover configurations in a future lecture. All right, let's make an assembly. So I'm going to make an assembly from part. I extruded them both 0.25 inches. Although honestly, it doesn't really matter how far you extrude. When we're working on assemblies, we always want to have our base piece, the thing that's moving the least, as the first thing we import. So if you don't see gear plate on here, just browse for it. And Caitlin, even if your gear plate is just a sketch, this will still work. And then click OK. And there's my plate and it's fixed, so it won't rotate. And then to that, I'm going to insert my other two parts. Now I prefer just to go into my folders here and just drag them in. If you don't want to do that, if you want to use insert components and then browse, that's fine too. And I'm going to mate these in position. So I'm going to mate the centers with my holes in the plate. And you can also make them with these sketch too, if you just want to make them to the sketch, that work fine. And then I want to have them so that way the kind of the front and the back plates are touching each other. Oop, that's not what I want. Undo. This face, I want to touch this face. And the back of this one, I want to touch the front of this one. And just to prove the point, now with my assembly, if I come back to my text file, I can change this, save it, hit rebuild, and all three parts automatically change their size based off what I need. And this is kind of the next level of complexity that you might add to a design where you're still planning on using off-the-shelf gears, but you want to better visualize the amount of space the gears are going to take up in the assembly. Does that make sense to everybody? This is where you would stop if you wanted to have an accurate model of how much space the gears were going to take up, but you didn't want to model the gears entirely. Or if you wanted to build a mock-up of the assembly without the actual gears, but still had a placeholder, a physical placeholder for these parts. I could 3D print these and then put them in, and I could have them roll against each other and make sure it still worked. That would be fine. They wouldn't transmit torque because the friction would be the only thing holding them together, and so their ability to commit power would be bad. But they would still have the same motions that they're supposed to have. So I could do a kinematic analysis with a physical model with these parts, which could be valuable. Does that make sense? All right. The next thing we're gonna do is we're gonna make these into actual gears, but they're gonna be Flintstone gears. They're not gonna have an involute curve. They're just gonna have teeth that kind of work. And we're gonna do that just to keep the complexity one step down from the final piece. And we may have to stop because we're running close to the end of the class, but when we get to the end of the class, just give me a shout out and we'll pause for there. Okay. I'm gonna open one of my gears. And just as a quick note, if I have a gear tooth, I really don't want the contact portion, the portion that I'm using to calculate the gear ratio, to be at the tip of the gear. I want it to be really along the middle of the gear. So the diameter of the gear, the effective diameter is not the absolute diameter, it's more like the middle diameter. So the first thing I'm gonna do is I'm gonna make these circle wider by half the pitch, and then I'm going to cut the pitch into the gear. Does that make sense? So on this gear in, and if yours is a different size, don't worry about it. As soon as I change my gear ratio here, and I can go back to 2, save, update. I'm going to edit my first extrude. So that way this equation, again, I'm doing this just by double clicking on boss extrude 1. Now it shows me the equations. Click on the equation, really double click the equation. Then I click on the globe. Now I'm editing the equation that's driving that dimension. And I'm just going to say plus pitch, global variables, pitch divided by 2. So now this diameter is going to be half of the pitch larger than it was at the start. You see it got a little bit bigger. Still totally driven by the equations though. And now what I'm going to do is I'm going to draw the profile of a cutout of a tooth into the side of this gear. Anyone get stuck on that? Edit. Yeah, so if I click on the boss extrude 1, double click on the equation, I can toggle between this display. You probably will see a globe there. When I click it, it lets it go from the output to the actual equation. And then I can actually edit in here. And what I'm doing is I'm adding half of the pitch divided by 2. When I do the plus, I use this global variables and then select it out of the dropdown. I use this selection out of the dropdown just to make sure I don't spell something wrong. And then I'm using parentheses just to make sure I'm getting the correct math. I worry about order of operations. It should do the division before it does the addition, but I like to be explicit. The equation? There we go. One. Dimension. Does anyone else having an issue where it's not letting them edit the dimension? Have you saved the part, Keelan? Yeah. It's not letting her change the dimension at all.
No, I'm saying it's the final.
You can cancel here. Go to tools. Equations. Okay, so you have it set here. Erase those. Okay, so I figured out what happened in Caitlin's. On her equations, when she linked to the external file, she had the dimensions for the sketch in that file. And since it was in the file and linked to the file, it won't let you change it in the part. So just like they're all grayed out in my equations here on this one, I can't change these because it's pulling them from the file now. So anything you put inside the file, you can no longer edit in SOLIDWORKS. Does that make sense? Okay. It's like a one-directional relationship. Did that fix it, Keelan? still have the equation there. And it's just an error. So even after deleting it from the file, the equation were still inside her list of variables. It was just throwing an error instead of having it unlink. So I'm not sure if there's a way to unlink the files. Probably what we could have done, Caitlin, which would have been better, just gone through and just clicked on the little check boxes here to unlink those equations from the file. And then that probably would have worked without having caused an issue. I just wasn't expecting that to be a problem. All right. Yeah, we have a little bit of time still. So let's go ahead and I'm going to sketch on the front of this. And what I want to do is I want to set up some parameters that I can use to control the size of the teeth in this gear. So I'm going to draw 3 additional circles. And what these are going to represent are, this is my outside diameter that I just set. I have the contact diameter. I kind of have what I call the minimum diameter. And then I have a little bit of a clearance here. And Stephen, this is a little bit different from what we have inside the document. So you might want to look at this as well. So in here, this first one in, this is going to be the actual diameter where my contact halfway down the tooth is going to be. So I'm going to set that equal to my global variables, my diameter in. This one, the next one, I'm going to do minus half of my pitch again. So I'm going to say equals to global variables, diameter in, minus global variables, pitch divided by 2. And then this last one, I'm just going to offset from this inner circle. So I always have some amount of clearance between my gears. I'm going to set that as 0.01. I'm using small values here because my pitch is only 0.1. So if my pitch was bigger, these gaps would be bigger. And we can change that if we decide that these teeth are too small after we make our gear. This last circle is 0.1 inches, 0.01 inches from this inner one, which is the diameter in minus 1/2 the pitch. So I have a line which is half of the pitch in from the contact point, half of the pitch out from the contact point, and then a little bit of a clearance. And what I'm going to do is I'm going to make these 2 middle ones construction lines. Oop, cancel. So I'm going to make this a construction line. I'm going to make this a construction line. And then I'm going to convert this outside edge to give myself an outside face. And then I'm going to draw a trapezoid around that. We are at the end of time. So I'm going to stop and pause there. And I'll save this. I'm going to pick up in class on Wednesday. Hopefully we'll have time to do a simple gear, an involute gear, and then show how we can do the mechanical mates inside of the assembly to make the 2 gears work the way they're supposed to. I'm going to stop the recording.